So in this I will be explaining a limiting moment of resistance index. So from IS 456 2000, that is in Annexure G, page number 96. Page number 96. So let me open the code on page number 96. So we have a equation, a limiting moment, mu limit equals 0.36 xu max by d into 1 minus 0.42 into xu max by d into bd square fck. Let me copy the same equation. So the equation is mu limit equals 0.36 xu max divided by d into 1 minus 0.42 into again xu max divided by d into bd square fck. Okay, so this can be written as mu limit divided by fck bd square equals 0.36 multiplied by xu max divided by d into 1 minus 0.4242 into xu max divided by d. So this is equation number 1. So here in this equation, the ratio mu limit divided by fck bd square, so it is a constant. So this constant we will call it as limiting moment of resistance index. So this constant is called as limiting moment of resistance index. Clear? So again, if you refer IS 456 2000, page number 70, or you can refer SP 16 table B on page number 9. Page number 9. So you have different grades of steel and corresponding xu max by d values. So for 250 grade it is 0.53, for 415 0.48, for 500 it is 0.46, for 550 it is 0.44. So let me verify the code. So page number 70. See here, various grades of steel and corresponding XU max by D values. This is IS 456. In IS 456, it is page number 70. Similarly, if you refer SP 16, so if you refer SP 16, it is on table B. So you have different grades of steel and corresponding XU max by D values. So now I will substitute these values in equation number 1 and evaluate the limiting moment of resistance index for various grades of steel. Clear? So first I will copy equation 1. So equation 1 is mu limit divided by FCK BD square equals 0.36 into XU max divided by D into 1 minus 0.42 into again XU max by D. This is equation number 1. So first I will evaluate limiting moment of resistance index for mild steel. So for mild steel, its grade will be 250. For 250 grade, XU max by D value, so it will be 0.53. So equation 1 can be written as mu limit divided by FCK BD square equals 0.36 multiplied by 0.53 multiplied by 1 minus 0.42 again multiplied by 0.53. Okay, so let me solve this. So 0.336 multiplied by 0.53 again multiplied by 1 minus 0.42 into 0.53. So it will be 0.148. So mu limit divided by FCK BD square. So it will be, so after simplifying this term, so it will be 0.148. So this also can be written as mu limit equals 0.148 FCK BD square. So this is for mild steel or Fe 250. So I will call this as equation number 2. So similarly calculate it for other grades of steel. So next for Fe 415 grade, for Fe 415 grade steel, first let me note down the XU max by D value. So it is 0.48. So again your equation 1 becomes, so equation 1 becomes mu limit divided by FCK BD square equals, so 0.36 multiplied by, so XU max by D value 0.48 multiplied by 1 minus 0.42 into 0.48. So mu limit divided by FCK BD square equals. So let me solve this. So in the same equation 0.53 replaced by 0.48. So it will be 0.1379. So it can be taken as 0.138. So this can be written as mu limit equals 0.138 FCK BD square. So I will call this as equation number 3, and this is for FE 415 grade. So similarly calculate it for 500 grade steel. So first let me note down the XU max. XU max divided by D, it will be 0.46. So equation 1 becomes, so here mu limit divided by FCK BD square equals 0.36 multiplied by 0.46 multiplied by 1 minus 0.42 into 0.46. So on left hand side it is same, mu limit divided by FCK BD square equals, so let me solve this. So instead of 0.48 it is 0.46. So it is 0.133. 0.133. So this can also be written as, mu limit equals 0.133 FCK BD square. So this is equation number 4, and this equation number 4 is for FE 500 grade steel. FE 500 grade steel. So for FE 550, so for FE 550 grade, so first let me note down XU max divided by D value. So it is 0.44. So this value, it is not available in IS 456. For this value, you can refer any of your reference books or textbooks. In the first lecture, I have evaluated the XU max by D values for 550 and 600 grade also. So let me check it. So in first lecture, see here. So for 550 grade, it is 0.44. So for 600 grade, it is 0.43. Clear? So XU max by D equals 0.44. So equation 1 becomes mu limit divided by FCK BD square equals 0.36 multiplied by 0.44 into 1 minus 0.42 into 0.44. So mu limit divided by FCK BD square equals. So let me simplify this. So I will use the calculator. So in the above equation, instead of 0.46, it is 0.44. So it is 0.129. So this can also be written as mu limit equals 0.129 FCK BD square. I think this is equation 5. So this is equation number 5, and this is for FE 550 grade. FE 550 grade. So finally evaluate it for FE 600. So XU max for FE 600 grade, XU max by D value. I think it will be. So refer first lecture. For 600 it is 0.43. So it is 0.43. So equation 1 becomes mu limit divided by FCK BD square equals 0.36 multiplied by 0.43 multiplied by 1 minus 0.42 again multiplied by 0.43. So mu limit divided by FCK BD square equals. So let me simplify this. So in the above expression 0.44 is it has to be replaced by 43. So it will be 0.126. FCK, sorry, 0.126. Later it can be written as mu limit equals 0.126 FCK BD square. So this is equation number 6. So this is for FE 600 grade. So just I'll summarize this. So first I have a reference equation for mu limit. It is 0.36 into XU max divided by D into 1 minus 0.42 into XU max divided by D into FCK BD square. So this equation, it is available in IS 456. So here mu limit divided by, I will take FCK BD square here in the denominator, FCK BD square. So equals, so 0.36 XU max divided by D into 1 minus 0.42 into XU max divided by D. Clear? So this is your equation number 1. So in this equation, for any given section, so this will be a constant. We call this constant as limiting moment of resistance index. So this ratio, it is called as limiting moment of resistance index. We have evaluated the limiting moment of resistance index for various grades of steel. So let me list all the equations. For Fe 250, so equation will be, so mu limit equals 0.148 FCK BD square. For Fe 415, so limiting moment of resistance index, so it will be 0.138 FCK BD square. So Fe 500, for Fe 500, mu limit equals 0.133 FCK BD square. For Fe 550, so mu limit equals 0.129 FCK BD square. For Fe 600, for Fe 600 grade, what is the value? 0.126. So mu limit equals 0.126 FCK into BD square. So this is in equation number 2. These equations are already derived. 3, 4, this is 5, and this is 6. For Fe 250, 415 and for 500, these equations are available in, readily available in table C of SP16, that is on page number 10. So let me check the code. So table C, yes, here you have table C on page number 10, limiting moment of resistance. So for 250 grade it is 0.149, For 415 it is 0.138. For 500 it is 0.133. Again in IS 456 and in SP 16 you have only 3 grades of steel: 250, 415 and 500. So here we have evaluated, in addition to these 3 grades, we have evaluated the equation for FE 550 and FE 600 grade also.